All right, today we're going to talk about chapter 6 here. Starting in chapter 6, Angles and Polygons, section 6.1. Good news is we are pretty much done with triangles. So chapters 4 and 5, very heavy on triangles. Now we're moving into more complex angles and polygons. A lot of this chapter is going to focus on quadrilaterals, actually. But start us off, we're going to talk about angles and polygons, section 6.1. First thing we're going to talk about is an interior angle. When you think of the word interior, what do you think of? Inside. Okay, so an interior angle is an angle on the inside of the polygon. So we're very familiar with triangles. If you look at a triangle here, that would be like an interior angle. It's an angle on the inside of the triangle. Pretty straightforward. Exterior angle, when you think of the word exterior, what do you think of?
Outside.
Outside. Okay, so an exterior angle would be if I were to extend the line of this triangle, that right there would be my exterior angle. It's an angle that's formed on the outside of the triangle. And then we have two things here, two kind of formulas we're going to talk about. The measures of interior angles of a convex polygon. The sum of the measures is n minus 2 times 180. Now, what do you think of when you think of sum? What does sum mean?
Addition.
Add. So that means like all of the angles added up. If I wanted to find out what all the angles of a certain shape were to add up to, I would take this formula right here, n minus 2 times 180, where n is the number of sides. N represents the sides. So for example, like a triangle, how many sides does a triangle have?
3.
3. I would plug 3 in there. 3 minus 2 is 1. 1 times 180. Well, we already know the interior angles of a triangle add up to 180, and that just kind of proves that. Okay? And then we have the measure of an interior angle. The measure of an interior angle means what's the exact measure of one of the regular inside angles. So notice it's very similar. It's n minus 2 times 180. But now I'm going to add, I'm dividing by n. So again, let's think about a triangle. How many sides does a triangle have?
3.
So I'd be like 3 minus 2 times 180 divided by 3. What's 3 minus 2? 1. 1 times 180 is 180. 180 divided by 3 is 60. So in a regular triangle, all of the angles are 60 degrees. What type of triangle would that be? Equilateral or equiangular. Either way you look at it, it'd be this exact same thing. Okay? So if you look at the properties of a triangle, this checks out. Now we're going to use those properties and apply them to more complex polygons. All right, here are some of the qualities of a polygon. Kind of shows us a quadrilateral here. You have the side. A side goes on the outside, kind of formed right there between the vertexes. A vertex is where two sides meet. They form the vertex. And then we have a diagonal. A diagonal is anything that's formed without two consecutive vertices. Okay, so you can't form a diagonal with consecutive vertices. They have to be non-consecutive. All of the names of the polygons are here. An n-gon would be like where we just call anything beyond 10. They do have names for a lot of them, but it's like you don't see them very often, so there's no point in memorizing it. Like these are the most popular ones, like 3 is a triangle, familiar with that. 4 is quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is a heptagon. 8 is an octagon. What's a famous octagon you see all the time? Stop sign. 9 is a nonagon. 10 is a decagon. The only other one I would include and add to this list is 12-sided. Does anybody know what a 12-sided shape is called? Does anybody know 12?
Oh, I know this one.
Dodecagon. It is dodecagon. So that's the only one I would add to this list. A 12-sided shape is a dodecagon. And then we have the regular polygons down here at the bottom. A regular polygon has all the sides congruent and all the angles congruent. In a triangle, a regular triangle is called an equilateral, equiangular triangle, right? All the sides are the same, all the angles are the same. In a quadrilateral, what's a regular quadrilateral called?
Not.
That'd be a square. All the sides are the same, all the angles are the same. Anything beyond that, you can just call like a regular pentagon or a regular hexagon, regular heptagon. Again, regular means all the sides, all the angles are the same. And then we're going to talk about convex and concave. A convex polygon would be all the diagonals lie in the interior of the polygon. And then a concave polygon is all or part of at least one diagonal that lies outside the polygon. When you think of the word concave, what's kind of a word in there? Caved. When you think of caved, I always think of like a pop can. If you take a pop can and kind of push in on the sides, what happens to it?
It goes in.
It goes in. It caves in. That's a concave polygon here. So if you think of the example right down here of a concave polygon, that'd be like taking your thumbs and pushing a pop can and it's caved in. Okay, that is concave. Then convex is just your one that's all on the outside, kind of your more regular. Then we have a regular polygon. Again, all these sides, all the angles are the same. That'd be an example of a square there. So let's use what we learned here. Let's talk about it. So we want to tell whether each is a polygon. If it is a polygon, name it by the number of sides. So first off, number 1, is that a polygon?
Yeah.
Yes. How many sides does it have?
5.
That would be called a
Pentagon.
pentagon. 2, is that a polygon? Yes. How many sides does that one have? 7, so that'd be called a
Center.
heptagon. Nice job. There's a poster right here for them all. And 3, is 3 a polygon?
No.
3 is not a polygon. Why is 3 not a polygon?
Because it's rounded.
It's curved. Polygons cannot be curved. There are 3 kind of main things that polygons cannot be. They cannot be curved. Polygons cannot overlap sides. So for example there, if I were to draw like kind of an hourglass shape up top there, that is not a polygon because the sides cannot overlap. And polygons have to come together. Would that be an example of a polygon? No, because all the sides are not formed together. Okay, polygons have to be formed together. So let's look at number 4, 5, and 6 here. First, once we tell us whether each polygon is regular or irregular, then tell whether it is concave or convex. So first one before, is that regular or irregular, Reed?
Irregular.
That is irregular. Why?
Because it has different
I just
angles.
put ears.
It has different angles, different sides, right?
Yep.
Is that convex or concave?
That would be a convex.
That'd be convex.
I just put ear for that.
Nice job.
What?
Irregular, like ear.
It's your notes. It's fine. 5. Regular or irregular? Colton, what are you thinking? Why is it regular?
Ear con.
Because why? Did you say it's symmetrical? What does it mean to be regular? All the sides and all the angles are going to be the same. So they're all the same there. So it's regular. Is that convex or concave? Convex. Now, here's a question for you. I want you to think about it before you answer. Is there any way a triangle can be concave?
Yes, it could.
Show me.
Upside down.
Yeah, it's right there.
Is there any way a triangle can be convex?
It would be a triangle.
Or sorry, concave. Is there any way a triangle can be concave? No, a triangle cannot be concave. A lot of times people go like, oh yeah, number 6 though. But what type of figure is number 6 actually?
Arrow.
It's a quadrilateral. Why is it quadrilateral? There's 4 sides. That makes it a quadrilateral now. So is that a regular or irregular quadrilateral? That is irregular.
It's concave.
And then, as we've mentioned already, it would be what?
Concave.
Concave. Jeez. Messing up slow.
Good at this.
Yep. Next thing we'll talk about here is the Polygon Angle sum theorem. This states that the sum of the interior angles measures of a convex polygon with n sides is n minus 2 times 180. This is the sum of, so all of them added up. Again, a quadrilateral. Quadrilateral has how many sides? 4. So you'd plug it in. 4 minus 2 times 180. So 4 minus 2 is 2. 2 times 180. A quadrilateral will always add up to 360. Some of us probably already knew that already, didn't we? If you think about a rectangle, a square, all those different shapes, we probably already knew that. But we can use that same formula now to show a hexagon and a decagon. All right? Now, if you were to think about it here, let's say I go from a triangle to a square. A triangle, the interior adds up to what? 180. A quadrilateral interior adds up to, every time I add a side, how many degrees am I adding?
Double the
I'm adding what?
180.
180. Every time I add a side, I'm adding 180. Here's kind of why. If you look at it this way. A triangle. How many degrees is a triangle? What's the interior of a triangle add up to? Everybody agrees with that. We've been proved that early on. Well, let's look at a quadrilateral here. Quadrilateral adds up to what? Well, if I were to draw a diagonal in here, how many triangles can I make there? 2. Each triangle is 180, right? 180, 180. I get 360. Let's draw a pentagon here. If I draw the diagonals in here, how many triangles do I have here? 3. So now it's 540. So if you think about it, every time I add a side, basically I'm adding an additional triangle there. Give me another 180 degrees worth of angles. Okay? That's kind of why, that's kind of the thing that proves that. So let's use what we know there. Number 7. I want to find the sum of a polygon's interior angles. Okay? So I'm going to take n minus 2 times 180. A pentagon has how many sides, Luis? 5. So I'm going to say 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 gets me the sum of the angles is 540 degrees.
So 5 minus 2.
Good job.
3.
That's the answer right there.
Yeah, I was doing that while you were
8. An octagon. How many sides does an octagon have? Hannah. 8. So I'm going to say 8 minus 2 times 180. 8 minus 2 is 6. 6 times 180 gets me how many angles? Or how many degrees? 1080 degrees. Ah. Nice job. And 9, a heptagon. How many sides does a heptagon have? Parker. 7 sides. So we're going to say 7 minus 2 times 180. 7 minus 2 is 5. 5 times 180 gets me 900 degrees. Nice job. So again, that's when we want to find the sum of a polygon's interior angles. After that, we can find the measure of an interior angle. So if I want to find the measure of an interior angle, I'm going to do the same thing. N minus 2 times 180. And I'm going to divide it by n. Why am I dividing that by n? Because I'm dividing it by what, Chris? The number of sides also is the number of angles. So if I find the sum of the interior angles and then divide it by how many angles it is, that tells me what each angle of a regular polygon has to be. So if you notice, it's the same formula, n minus 2 times 180 divided by n. So I'm adding one additional spot here. So if you think of quadrilateral, which we've already done, quadrilateral is 360. If I take 360 and divide that by 4, then I get 90 degrees. And that'd be true, right? Think about a triangle. We did the triangle earlier. 180 divided by 3, and we got 60. Each angle is going to be 60. That makes sense. Okay? And the very last thing we're going to talk about here is the Polygon external angle sum theorem. States that the sum of the exterior angle measures one angle at each vertex of a convex polygon is 360 degrees. The measure of each exterior angle of a regular polygon with n exterior angles is 360 divided by n. So the measure of each exterior angle of a regular decagon is 360 divided by 10, or 36 degrees. What this means, okay, think about the exterior. If I were to go all the way around a shape, for example, I have a triangle here. If I were to start right here and go all the way around that shape, right? I'm doing the exterior angles. What did I just make there? A circle. How many degrees is a circle? 360. Henceforth, why the exterior angles always add up to 360. I can do that for another shape here too. Let's think of a square, or it's a quadrilateral. If I start right here and go all the way around, what did I just make again? Circle. Circle is 360. Exterior angles will always add up to 360. That's what that is stating right there. Okay, and we'll look at that again here at the end. So last thing, I want to find the measure of an interior angle. So if I want to find the measure of an interior angle, I'm going to take n minus 2 times 180. And I'm going to divide that by n. And what does n stand for again, Spencer? Yeah, what's n stand for?
What?
Number of sides. So an octagon, Spencer, how many sides does an octagon have? 8. So I'm going to say 8 minus 2 times 180. I'm going to divide that by 8. Well, what's 8 minus 2? 6. 6 times 180 is? Is it 1080?
Yeah.
So I take 1080 and I divide that by 8 now. And each measure of an octagon would have to be what then?
135.
135 degrees. Nice job. A triangle. Caden, how many sides does triangle have? So 3 minus 2 times 180 divided by 3. What's 3 minus 2, Caden? 1 times 180 is? So I take 180 and divide that by 3. And what's each angle going to have to be, Caden? 60 degrees. Nice job. A pentagon. Tyler Wilson, how many sides does a pentagon have? So 5 minus 2 times 180 divided by 5. So I would do 5 minus 2, which is 3. 3 times 180 is what, Tyler? 540 divided by 5 gets me what, Tyler? 108 degrees. Nice job. Take a couple seconds, do number 13 on your own.
Man.
All right, let's walk through this one. Jake O'Connor. Hexagon has how many sides?
6.
So I'm going to say 6 minus 2 times 180 divided by 6. So what's 6 minus 2 times 180, Jake? 720 divided by 6. What's each angle going to be, Jake? 120 degrees. Nice job. Last thing we're going to talk about here is finding the measure of an exterior angle. We kind of already talked about this. I'm going to start off by finding the exterior angles. So if I were to look at this angle right here in red, what would the measure of that exterior angle be? Simeon, what's the measure of that exterior angle? What?
I got it.
What would it be? Like this is a line. How many degrees is a line? So 180 minus 87 gets me? 93 degrees. Nice. What about this angle right here? Quinn, what's that angle up top there going to be? Next to 107. Okay. This angle right here, Ty, what's that one going to be?
No,
77 degrees. And what about right here, Trent? What's that one going to be? $117 degrees. Nice job. Somebody real fast. Add up all 4 of those angles. 93 plus 73 plus 77 plus 117. If you add up all 4 of the exterior angles, what do they add up to? They would all add up to 360 degrees. Kind of shows that. 15. Let's try 15. Same idea here. Anderson. This angle right here in red, what's that exterior angle going to be? 115? McCoolidge. This one angle right here. $180 minus 54? 126. Read, what's the next one?
119.
If I add up all three of those angles, what do I get? 360 degrees. What are the extra angles always going to add up to? 360 degrees. Kind of shows that. Nice job. Here's your assignment today.